Let us begin the series on reduction formula with the integral of x to the n e to the power of x dx. Alright, so we are going to consider the reduction formula for this particular integral. Reduction formula for the integral of x to the n e to the power of x dx. To do this, we use the technique of integration by part. For integration by part, the integral of u dv is equal to uv minus the integral of v du. So what will I choose as u? What will I choose as dv? Like I have said in one of my videos on integration by parts, that the one we choose as u is the part that will actually turn to 0 after successive differentiation. If I differentiate x to the power of n successively, let's say n is a number, you get, let's say n is 5, let's say it is s to the power of 5. If I differentiate this function successively, after some time it will turn to 0. Okay, so I should choose x to the power of n as u. So I will say let u be equal to x to the n, so that differentiating u with respect to x du dx is n times 1, which is n, into x to the power of n minus 1. If we cross multiply, du will be equal to nx to the n minus 1 dx. Now, we have chosen this as u. We now choose the other part of it, which is e to the power of x dx, as dv. U is x to the n, dv is e to the power of x dx. So let dv be equal to ex dx. To get v, we integrate both sides. The integral of dv is v, and the integral of the exponential function e to the power of x with respect to x is still e to the power of x. So using this, the integral of x to the n e to the x dx is now equal to u, which is xn, times v, which is e to the power of x, minus the integral of v. V is e to the power of x du. What is du? Du is everything here, which is times nx to the n minus 1 dx. Alright, this will actually give us x to the n e to the x minus n is a constant because we are integrating with respect to x, so I can bring the n outside. Alright, so what's left? The integral of e to the x times xn minus 1 dx. This is x to the n e to the x minus n integral of, let me write this one first, Sn minus 1 e to the x dx. That is the integral of xn ex dx is equal to this. Now, it is called reduction formula. So we don't have to integrate this anymore. We just have to determine a pattern that will work for it. See, let I sub n be equal to this integral, the question we are given, the integral of x to the n e to the power of x dx. If we check this I sub n, which is this integral, it is similar to this, just that in place of n here, we now have n minus 1. E to the power of x remain, dx remain. So let us call this particular one I sub n minus 1. So it's like we're saying that this integral is a function of n, while this one is a function of n minus 1. So this is the integral of x to the n minus 1 times e to the x dx. So therefore, I sub n is now equal to xn ex x to the n e to the power of x minus n. I will not write this integral again. We have already said that this integral is equal to I sub n minus 1. So I'm writing I sub n minus 1. This is the reduction formula for the integral of x to the n e to the power of x dx. Now, what if we are to determine a reduction formula for the integral of x to the n e to the power of kx dx? Alright, the one we determined just now does not contain k. Using the integration by part formula, if we say let u be equal to x to the n, it means that du dx is equal to nx to the n minus 1. And let the v be equal to e to the power of kx dx. To get v, we integrate both sides. The integral of the v is v, alright? The integral of e to the power of kx dx is e to the power of kx all over k. So using the formula, the integral of x and e to the power of kx dx is equal to uv minus the integral of v du. U is x to the n, v is e to the power of kx all over k, minus the integral of v, which is e to the power of kx all over k, and du. If we cross multiply, du will be equal to, that's n x to the n minus 1 times dx. Alright, see, n over k is a constant here. This is equal to 1 over k into x to the n e to the power of kx minus n will come out all over this k into the integral of x to the n minus 1, okay, e to the power of kx dx. This integral is equal to I sub n, alright? So if that is I sub n, this one will now be what? I sub n minus 1, because n minus 1 here is standing in place of n. So I sub n is equal to 1 over k into x and e to the power of kx minus n over k I sub n minus 1. 1 over k is common to the two terms that we have here. So I can write this like this. I sub n is equal to 1 over k all into x to the n e to the power of kx minus n I sub n minus 1. Now, the first question here says, use a reduction formula to determine the integral of x to the fourth e to the power of x dx. So based on the reduction formula that we deduced earlier, the integral of x to the n e to the power of x dx is simply x n e x minus n I sub n minus 1. Okay, this is I sub n. The integral of x to the power of 4 e to the power of x dx. In this case now, n is equal to 4. So we can say I4. So we say this is x to the power of 4 e to the power of x minus 4 into I. 4 minus 1 is 3. The question is, what is I3? I3 is simply the integral of x cubed ex dx. You agree with me? If this is I4, then this will be what? I3. This is equal to, applying the same reduction formula, to be x cubed ex minus 3I, of course, 2, because I is 3. Understand the process. We are looking for I4, but along the line, I3 appears. So we have to break it down until we get to I0. Okay? What is I2? Which is the integral of x squared ex dx is equal to x squared ex minus 2 I 2 minus 1 is 1. What is I1? I1 is the integral of x to the power of 1, and that will be x ex minus 1. You know, n is 1 now. So 1 times everything there is still what we have here. 1 minus 1 is 0. So we can easily determine I naught. Okay, it's simple. I naught is simply the integral, you get it now, of x to the power of 0 e to the power of x dx. So x to the power of 0 is 1, so we are just left with the integral of e to the power of x dx. And if you integrate the exponential function, you will still get the e to the power of x, right? That's it. So let's neglect the constant of integration. So I naught is e to the power of x. So I4 is equal to, I'm coming here now, x to the fourth e to the power of x minus 4. I want to open a bracket. What's I3? S cubed ex minus 3I2. S cubed ex minus 3I2. Let's expand. This is s to the fourth e to the power of x minus, okay. Let me use minus 4 to multiply this bracket. We have minus 4 s cubed ex plus 12I2, right? That's it. So the question now is, what is I2? So I4 will be s to the fourth e to the power of x minus 4s cubed ex plus 12 in bracket. Now what's I2? This is I2. S squared ex minus 2. Okay, let me just write I1. I'm supposed to write I1 now, right? But I1 is everything here. So I'll put in bracket xex minus I naught. So I4 will be equal to x to the fourth e to the power of x minus 4s cubed ex plus 12 into s squared ex minus, let's open this bracket now, minus 2 times xex is minus 2xex minus 2 times minus I naught is plus 2I naught plus 2I naught, right? But I naught itself is this. So I'm done. I will add a constant of integration to it. So let me simplify. I4 is s4 ex minus 4s cubed ex. So the bracket will multiply, the 12 will multiply the bracket. That will be 12s squared ex minus 24xex plus 24ex, right? Plus the constant of integration. So I can choose to factor out ex, okay? If I leave it like this, I'm still correct. ex is common to everything. That's e to the power of x. So if I will have x to the fourth minus 4s cubed plus 12x squared minus 24x plus 24 plus the constant of integration. We have to determine the integral of 5t cubed e to the power of 2t dt, and hence we have to evaluate this, okay, to 3 decimal places. Now remember this. For a coefficient of k, that is, if t has a coefficient of k, I think we derived the reduction formula just now that says In is equal to 1 over k into, let me use t now since we are working with t in this particular question. T to the power of n e to the power of k t minus n into I sub n minus 1. That's what I'm going to use now to evaluate this integral. Okay. Now, I sub n in this particular case is this, the integral of t cubed e to the power of 2t dt. But since we have a 5, which is a constant actually, the 5 can come out. So if I bring it out here, I will multiply this one by 5 as well. So in essence, we are determining 5in. N is 3, right? N is 3. If you compare, N is 3. So we are saying 5. Okay, this is 3. Let me just put the 3 here. So 5i3 is equal to 5 into, let me evaluate this particular integral now using this. So to be 1 over k is 2 in bracket t to the power of 3 e to the power of 2t minus n is 3 I2, right? What is I2? I2 is this, the integral of t squared. The power of t will now be 2, that's why it is I2. And e to the power of 2t dt. Repeating the same process using the same reduction formula to be 1 over k. K is always 2 in this particular case, into what is Tn? It will now be t squared e to the power of 2t minus n is now 2, right? 2 minus 1 is 1. The question is, what is I1? I1, I think we should be simplifying this, yes, so that to be easy for us later. This will be, k is 2. Why did I write k here? I'm supposed to write 2. So if I use 1 over 2 to multiply this bracket, I will have 1 over 2 t squared e to the power of 2t minus 1 over 2 times this will give me I1. So this one is I2. Okay. Now what is I1? I1 is this, the integral of t to the power of 1 e to the power of 2t. I1 simply means n is equal to 1 dt. And that will be 1 over 2 because k is 2, right? Into t to the power of 1, that's 1, e to the power of kt, k is 2, 2t, minus n is 1, 1 minus 1 is 0, I naught. Lastly, what is I naught? I naught is simply the integral of t to the power of 0, e to the power of 2t dt. And t to the power of 0 is 1, so we are just left with the integral of e to the power of 2t dt, and that is simply 1 over 2 e to the power of 2t plus c. But let's neglect the constant of integration in this case. This is I naught. Therefore, 5i3 will be equal to this. We have 5, okay, let me multiply now. 5 times 1 over 2 is 5 over 2, or let's just go straight. By the way, see, this will give me 5 over 2 t cubed e2t minus 5 times 1 over 2 is 5 over 2 times this one. That will be 15 over 2 I2. To make it easy. So this is what I will write now for 5i3. So 5i3 is equal to 5 over 2 t cubed e to the power of 2t minus 15 over 2. In place of I2, I'm writing this right hand side because this is what I2 is. So I'll open a bracket now and write I2. 1 over 2 t squared e to the power of 2t minus I1. Okay, I want to write, okay, let me write I1 first. So let's expand. This is 5 over 2 t cubed e to the power of 2t minus 15 over 2 times this is minus 15 t squared e to the power of 2t all over 4. And 15 over 2, which is minus 15 over 2 times minus I1, is plus 15 over 2 I1. Now, I1 has a value 5I3 is equal to 5 over 2, 5 over 2t cubed e to the power of 2t minus 15 over 4 t squared e to the power of 2t plus 15 over 2. I1 is actually what we have here, right? Minus I naught. So this is 5 over 2 t cubed e to the power of 2t minus 15 over 4 t squared e to the power of 2t plus, if I multiply, I expand this bracket, 15 times 1 times t e to the power of 2t is 15t e to the power of 2t. 2 times 2 is 4. And 15 over 2 times 1 over 2 is 15 over 4 times minus I naught is minus 15 over 4 I naught. But I naught has a value which is 1 over 2 e to the power of 2t. So I'm done. I will add the constant of integration. So this is simply 5 over 2 t cubed e to the power of 2t minus 15 over 4 t squared e to the power of 2t plus 15 over 4 t e to the power of 2t minus 15 over 8, get it? E to the power of 2t plus c, the constant of integration. And this is 5I3. Now that we've gotten this, we now want to evaluate the integral from 0 to 1 of 5 t cubed e to the power of 2t dt. Let's see how we're going to do that. First of all, from here, which is we are trying to determine now from 0 to 1, right? I want to factor out 5. That will be t cubed e to the power of 2t over 2 minus 3 over 4 t squared e to t plus 3 over 4 t e to t minus 3 over 8 e to the power of 2t. So we are taking the integral from 0 to 1. So let's plug in the upper and the lower limits. We plug in 1 first for t. This is it. If I plug in 1 for t, this will be 1. So this will now be 2. 2 times 1 is 2. So this will be e squared all over 2. If I plug in 1 here, this will be 1. The same thing here, minus 3 e squared over 2. If I plug in 1 here, I'll be having 3 over 4 e squared, right? Minus 3 over 8 e squared. Minus, I'll plug in 0 now. 0 enters here, everything becomes 0. Everything becomes 0 here. Everything becomes 0 here also. But what we'll have here will be 3 over 8. Because 2 times 0 is 0. Anything to the power 0 is 1. So e to the power of 0 is 1. Remaining just 3 over 8. This is not 2, this is 4 rather. This will cancel this. What's left? Minus, minus. Okay, let's leave that first. I want to bring out a squared from that expression. So now be remaining 1 over 2 minus 3 over 8, right? Plus 3 over 8. So everything you see here is actually e squared over 8, right? Okay, which is 0.923 and so on and so forth. So I want to add 3 over 8 to that result. My calculator says it is equal to 1.298632 and so on and so forth. Then multiply by this 5 here. That's it. So everything is equal to 6.49. The question says to 3 decimal places. So I should stop at this 3. After 3 I have 1, but 1 is not up to 5, so I'll round it down to 0. So I'll be having 6.493. So 3 decimal places. This is the solution to that integral. And now you're done watching the video, don't forget to subscribe, don't forget to like, and don't forget to share this video with your friends and your classmates. And I believe by now you can solve or determine the integral of functions like this where we have higher powers of n, all right, just using a simple reduction formula. See you in the next one, reduction formula 2.